Right, if we can welcome Emina up to give us this next talk on materials.
Kia ora. Thank you for the invitation. It's exciting to be part of this gathering and to see all of you here and to participate in these conversations. So I have titled this talk Beyond Carbon Considerations because I'm very passionate about thinking beyond carbon considerations. So you will not hear anything about operational energy and you'll hear very little about embodied energy as well. So it's going to be mainly about other things that I think we should be also thinking about. I'll situate my talk within the context of me wanting to give this book the title Beyond Carbon Considerations, but then the publishers decided that it needed to be far more descriptive. Four of us co-edited the book. It has just under 700 pages and almost 50 people contributing, just under 30 chapters. And the conclusion from the whole process was that we all were learning stuff that we didn't know, and we all already knew lots. So there is a lot of kind of gaps in knowledge in what's actually happening with sustainability and toxicity of building materials in terms of manufacture, use, and disposal. And because the book is very expensive, I'm also going to share that currently it's on 30% off sale from Elsevier website. Almost everything else that I publish, I try to publish open access, so you will be able to find some of the kind of similar stuff open access, and I'll do more of open access. But every so often as academics, we need to kind of do stuff that is like this, expensive. Now, where do I come from? I come from thinking through what are the different parameters that we should really be considering when it comes to transformation of the planetary kind of systems. So currently, United Nations talks about triple planetary crisis. So climate change, air pollution, and biodiversity loss. So most of the time, we talk only about the first one, which is why I'm kind of changing the balance and talking about the other ones. When it comes to air pollution, currently, again, United Nations is saying that 90% of the world population breathe air not compliant with World Health Organization standards in terms of exceeding the VOC emissions. And we know that if ventilation rates is low, the buildup of VOCs could be higher, and trying to create passive housing, we might find ourselves in situations where we want to have low ventilation rates because that's really good for heating, cooling, whatever we are doing there. But then this could be kind of flip over there. Now, they also talk about the fact that there is about 7 million deaths per year associated with air pollution currently. And almost half of that is from solid fuel cooking. So a lot of that doesn't actually apply to developed countries like New Zealand. But there is still more than 4 million deaths that are attributed to other air conditions. Biodiversity loss is something that we are not talking about, although the keynote was talking about earlier today, and we really need to consider very seriously as part of what we are doing. And now I want to kind of contextualize some of these issues within the context of building materials and what they are doing. But there are other parameters that this list is simplifying and not fully including. Planetary boundaries is one of the frameworks that has been increasing in recognition worldwide in recent decades. And it really looks into a multiplicity of dimensions that we should be considering. On the first glance, you'll see that between 2009 and 2023, we have exceeded quite a number of planetary boundaries. We should be within the green, okay? But we are kind of generally orange. Now, climate change and CO2 emissions at this tiny little fraction here. And that's, for me, terrifying because in many ways, that is where we have made some gains, and we can talk about actually something is happening. The other stuff we don't even necessarily know about, and that's very disturbing. Now, this is one of my charts from the book that I have just mentioned at the beginning, and it took me some years of collecting data and actually extracting from some websites their temporary per year announced data to actually generate this, because this sort of information is not very, very available. It tracks two things. The dark bars are looking through synthetic substances on file, how many synthetic chemicals we have invented. Look at that. And the other one is looking into how much we are making synthetics, plastics in this case. So look at that. So they're both exponentially increasing, but some of the starting numbers here are already 250,000. They're not actually tiny at all. And the flip of that is that we are often inventing the same chemicals, finding that they have some useful properties, putting them into manufacture, but they haven't been tested. So when it comes to what do we know about chemicals that are in use, this is from European Environmental Agency not long ago. There is about 100,000 chemicals on the market that are most commonly used synthetic chemicals, despite the fact that we have invented many more. We don't use all of them in manufacture. And also, there is actually a kind of a lobby of old synthetic plastics manufacturers. The early compositions of plastics that took off in soon after the World War II tend to still dominate the market. A lot more has been invented since, but it's kind of not succeeding to arrive on the market because the big guys are big and getting bigger. Now, of these chemicals, we know that extensively understand characteristics of hazards and exposures for about 0.5%. Okay? Then for about 10%, we have fairly well recognized characterizations of their health impacts. Then we kind of have an idea, and then we have no idea whatsoever. So we're working with a gap in knowledge of 70 to 90%. Okay, that's very unsettling feeling that there is a big gap in knowledge that we kind of have in this area. Some of the things that are not captured in the kind of this aspects that I have introduced so far relate to humans, and sustainable development goals kind of bring in as aspects of production and how much equity we're putting into production and things like that. But also we really need to think about social justice and what's happening in terms of social justice. We know that we should be doing better than what we have been doing for a number of years and decades. And very often our very polluting manufacture is externalized somewhere in some poor country somewhere over there. And I'm taking a photo from an accident from 1980s in India, where a whole lot of people died because of an accident. Accidents happen everywhere in the world where we are playing with poisonous chemicals. It's not just that. Last year, there was a major train crash in the US, which ended up kind of releasing a whole lot of hazardous chemicals into the environment, and some of that burned and created really toxic smoke. So you know, we need to kind of keep reminding ourselves of these stories. They're just like earthquakes, infrequent events, but they have major magnitude of potential impact. And these we can control. Earthquakes we can't stop, as humankind has not learned how to stop earthquakes, but we can undo our practices and our making theoretically. And yeah, some of that gets played out in popular media as well. The other aspect that I'm really curious about, and this is something where I don't have enough information currently to tell you, but I'm really interested in what we're doing with our nutrient life cycle. So yes, we were hearing earlier today about importance of kind of taking nutrients and putting in carbon and putting it into wood and storing it in the building, and then that carbon is in the building. Good. But also those nutrients are in the building. Now, is that an issue? I have no idea. And I don't think that actually science knows whether that's an issue or not. Just as some years ago, we didn't know whether all the carbon that we were putting into the atmosphere was an issue or not. We simply do not have very good understanding. But I'm constantly thinking about migration of nutrients when we make biomaterials move from one place to another. What's actually happening here? And is that going to bite us one day? And one part of that is that we are putting sometimes as construction waste nutrients into landfills. And then in landfills, if they're properly done, they're concreted in, and then actually they kind of stay isolated from the rest of the world. If they're not, they're put under pressure, and then all sorts of crazy stuff is leaching out of them. So kind of like bad. But these are nice things. Timber is supposed to decompose and help new life in the forest, right? That's what it's meant to do. And you see the banner here, which I think is really cool. that it's also a crime scene because all of that waste is actually carbon that is going to be accounted against somebody, and it really shouldn't be going into waste. And as part of what I look into, I do all sorts of things related to building materials. So that includes waste, and that linear process of manufacture is really the problem. But I also look into material flows. So these are some really cool diagrams for one of the UN reports. That compare 1945 and 2015 material flows. And here you can see that we have overall much skinnier material flow, right? There is bugger all material going through that circularity compared to now. But also the composition has changed. This was mainly biomaterials, the green stuff, and a little bit of metal and a little bit of fossil fuel comparably, the blue and gray. Now we have an awful lot of minerals and metals that are in circulation. Compared to that, proportionally using less of biomass. And of course, there is a lot of fossil fuel, and we're talking about that. So the composition is problematic and the volume is problematic. In fact, global volume of global consumption of materials looks something like this. Worse than that. In the last, in about 15 years, first 15 years of the 21st century, we have used 1/3 of the materials that we have used before that for the whole 20th century. That's really huge. Now, that's a really bad story, but there is a flip to that bad story, and often we get bombarded with bad stories. So even though this is technically a digression from my talk, I have decided that after I spoke once not long ago without giving the bad story, the good story, that I actually need to always include the good story, even if it makes me kind of digress for a moment. Okay, so the bad story is an exponential increase. But then look, high-income countries here, we have had a drop. Oh, that's better. So where is the growth as exponential as it is? In upper middle income countries. China and India, more specifically, are really huge consumers. Now, that makes xenophobic, microscopic parts of us go all sorts of places. So let's look into what do we do with that. This is a series of visualizations, and you can find really cool visualizations if you search for health and wealth diagrams showing this sort of comparison, what the wealth of people has been doing compared to what the health of people has been doing in recent decades. So at the beginning of 20th century, we have, here we have India and China as these two big blobs. We have a whole lot of Western countries being these blue blobs, and these tiny little blobs that are red are Africa. So we have some countries that are a little bit better off, but actually it's fairly comparable. By the beginning of 21st century, the total has really increased. You can see that the health of people in the world has increased. Now, we want that, don't we? We want good health outcomes for everybody. That would be one good outcome for everybody. But then look into this last couple of decades. Tremendous change of which groups? Look at that growth of red and the shift of India and China towards being higher income, but also better in health. So some parts of the world that were really not benefiting from industrialization are properly benefiting now. And some of that growth is inherently really good, I think. Yeah. So we want to find a world that is going to be good for all the humans, help us all live good, long lives, not kill anybody, and somehow we make the planet work. So that's the objective here. And this is doing a whole lot of good, right? Even though it's a bad story. Then, so the other things to remind us is that some of the crimes that we're committing towards the environment now are not new. So this is a photo from Adriatic coast, where the hills in the background used to be densely forested until Romans cut them down to build their boats. And after so many years of erosion, that's a rocky hillside that nothing can grow on because erosion is full. That's how we have learned that we can do erosion, right? And that we can nicely kind of create some of those events, right? So, so that sort of stuff is not new. Humans have actually been transforming dramatically environment for a very, very long time. But some of it is accelerating, of course. And I do love these visualizations by African artist Dylan Marsh, who looks into mines, and the little ball of copper, which is a visualization in the middle of the mine, is the representation of the amount of copper that has been taken from that huge hole. And you can see Google Earth image of the same mine. And you can see how, these are huge scales. We have a little Eiffel Tower here as well. I took an image that has lower resolution because it has a whole lot of really cool pointers there. And we often don't think about these things as being part of the materials that we are consuming, but they are. And I reckon they're part of what we are kind of doing something about and we need to be aware of. This is where aluminium comes from. To get aluminium, we need to cut the forest, and then we need to scrap a whole lot of soil, put it some aside, and then we dig open mines, and it's highly polluting. And then I'm really honored that one wonderful student who is now attending the event here, Max, has done a beautiful analysis in this space, finding that aluminium that is coming to New Zealand, that is New Zealand aluminium, is actually mined like this from Aboriginal land in Australia. So we have social issues, toxicity issues, and they're displaced all around the place. They're in different countries, in different stages. And we as consumers and specifiers of materials often don't know these stories. So I think we need to kind of really change that. Many sources are talking about the fact that as we move towards higher performing buildings and start to address the energy crisis, operational energy demand is going to become smaller because energy is going to become cleaner. We're going to become more efficient in how we're doing things with energy, and embodied energy is going to become more of an issue. But embodied energy tends to be calculated through things such as LCA, and this is one of the kind of diagrams, just is conceptually summarizing what LCA is about, and it's theoretically accounting for everything, but it's not. It's not accounting for the social justice aspects that I have been kind of dribbling through. And there are a few other kind of components that are not fully accounted for. In fact, it has many other problems. So this is an article that has recently summarized a whole lot of buildings. They found 105 buildings that have done LCA assessments of the buildings and have been reported to scientific literature. And then they have said, actually, end of life stage of buildings is generally not considered, a lot of inconsistencies. Generally, it is energy depletion and global warming are the main kind of aspects that are being reported. And 3 out of 105 try to say something about human toxicity. So if we actually avoid some of these aspects, we're going to constantly work with limitations in the data that we have. So one of my students last year was working through different things that were including LCA, and this is a table from her thesis that is looking into insulation materials from one of the calculators currently used in New Zealand. And we have glass wool looking really cool and wool looking really bad, right? And that is because glass wool, I hypothesize, and it's really through the calculator, it's a really good example. Through the calculator, you can't find out why. You need to be guesstimating some of these things. So I'm guesstimating that glass wool does not count all the energy that has gone into glass to become the waste product. So it uses it as the waste product. It might even give itself some benefits from using the waste product. And then it gets made into glass wool together with binder. And after that, it can't go anywhere. It doesn't have a recycling path. It doesn't have any other path that going into the landfill. On the other hand, we know that we are running out of sand for making glass worldwide, that there are whole lakes that are disappearing because of the drenching of the sand. It's a bizarre thing. The more you drench, the lower the water table goes, and eventually the whole area no longer has water, easy access to water that they had before, and a whole lot of other ecosystem implications. And then that glass that we make from that sand that is so precious is infinitely recyclable unless we put it into fiberglass. Yeah. And the same can be spoken about. There are two different polyesters and look at the difference. And then for wool, we probably are counting all of the emissions from growing the sheep, not counting that meat could be consumed and that the sheep is growing for the meat. And I'm not necessarily lobbying for growing more sheep. We should be growing fewer sheep, but we should be using really well everything that we get from the sheep that we grow. So overall, my conclusion is that when it comes to building materials, we are in a position of four blind men describing the elephant. It's highly complex, okay? And the problem can look like a big, gigantic elephant. So how do you eat an elephant? One bite at a time. Okay, so thinking through all of these grim stories, which I often do in my work, I have ended up developing sustainability transition framework, which is looking into 4 different theories of transition and bringing them into one thing. And it says that as we, I don't know, for example, as we have, and I don't have enough time to introduce it properly, so I'll just very quickly introduce it. As we start to uptake new innovation, there is a period of confusion and chasm and tipping point where it might take off or might not take off. And some things really take off and go into uptake, like mobile phones have, and very few people in the world would be without one right now. In 1970s, we started talking about buildings needing to have insulation. Most countries in the world by now, especially developed countries, have some regulations that are including insulation, double glazing, and things like that. So transition is beautifully progressing when it comes to that. But then when it comes to some of the things that I have been discussing today, we might be actually already still in denial, most of us. And one of the really kind of challenging thing here is that as soon as there is a takeoff of something new, like Black Lives Matter and Me Too movement, you get protests against them. Yeah. Because those people who were properly ignorant and in denial that the change was needed, first react with anger. Yeah. And that anger then becomes the issue. So this is a group of people that is, in my view, very committed and highly proactive in making wonderful contribution in making improvements when it comes to energy efficiency. Yeah, so you are all leaders somewhere over there, right? So I'm saying, don't be overwhelmed and bogged down by all the grim stories that I'm giving you now. Try to move from your denial to move to some of this positive curve. And start paying attention that more of improvements and more information is going to keep coming to all of us just because of the type of transition that we're in. And there is going to be a series of different waves that we need to navigate over the coming decades. And as long as we are open to keep taking the new ones on board fast, we're going to do well. It's a small, good story, but that's all that I can manage. Thank you.